Hello everyone. Today we'll be going through AS A-level topic, which is main topic is electrons in atoms, and subtopic is evidence for electronic structure. And this is from Cambridge, Edexcel, AQA, and Oxford specifications. Keep in mind, to clear this electrons in atom main topic, you need to go through these 6 videos. Hopefully these are very helpful for you. You can go through the playlist and then cover this topic. Then next, if we start this one, how do we know? The question is, how do we know that electrons are arranged in atoms? What is the evidence for this? We can have evidence from basically ionization energy jumps. There are, if you see ionization energies, these are having jumps, which is proving the existence of main energy levels. What are those jumps? Basically, if we see this one, there is jump between this, its drop is this one, and similarly we can see the jumps. This is increasing, lithium and beryllium is increasing, so beryllium to boron is again decreasing. So these ups and downs, if we draw the graph between atomic number and the first ionization energy, which is measured in kilojoules per mole, if we draw the graph, this will be this type of graph we will be getting. So these jumps are a proof that energy levels are existing. Further, trends and dips across a period prove the existence of subshells S, P, and D, and the effect of electron pairing. One more evidence we can discuss, which is basically atomic emission spectra, which proves that energy levels are quantized and unique to each element. So electrons revolving around the nucleus are in fixed orbitals, and like for example, this is nitrogen spectrum, sodium spectrum, hydrogen spectrum. So this spectrum is also a proof that the electrons are arranged in atoms. Then successive ionization energies also we can discuss. The energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. 1 mole of electrons from 1 mole of gaseous atoms, and this is measured in kilojoules per mole. This should be in gaseous state. And this is the diagram. If we go through, this side is nuclear charge Z, and this side is the ionization energy, kilojoules per mole. And these are like, first of all, key evidence: a large jump in energy indicates the removal of an electron from a shell closer to the nucleus. So large jump in energy indicates the removal of an electron from a shell closer to the nucleus. Similarly, if we see this one, hydrogen is having only 1 electron, so lesser energy is required. Up to this one, you can say like 1300, like that. But for hydrogen first ionization, because hydrogen is having 2 electrons, so filled orbit, so it's difficult to remove from here, so it's having higher ionization energy. Further, if we take example of aluminium, first and second, third ionization energy is relatively low, removing electrons from 3p and 3s orbitals. So these are relatively lower. So fourth ionization energy, very large jump. This proves that fourth electron is being removed from the N2 shell, which is closer to the nucleus and has less shielding effect. So this is what in case of aluminium we can discuss. Further, we can go to the trends across the period, and ionization energies are measured under standard conditions. This is what we know. The general symbol for ionization energy is IE, and units are kilojoules per mole. And if we see the periodic chart trends, this side is from left to right, it is increasing, and from down ionization energy is decreasing. This is also you should know. The symbol for first ionization is 1 E1, so you can say IE1, so ionization energy 1. And calcium, we can take calcium as an example. So first ionization, if we remove one electron from calcium in gaseous state and change it to atomic state, this one basically we are removing one electron, so this much energy will be required, and this is how we are representing this electron with minus sign. And the second ionization also, second ionization energy also we can show like this one. So this is how we are showing first, second and third ionization energies, and you can see ionization energies for second, third are also increasing. Remember that the first ionization energy IE1 is the energy required to remove the most loosely bound, which is the outermost electron will be first ionization energy, and the second ionization energy is the energy required to remove the second most loosely bonded. So second loosely bonded, and then the energy required to remove third electron in the third is the third ionization energy, which we can show IE3. So and so on, we can find fourth and fifth ionization energies also. Now the question is, what are the factors which are influencing ionization energies? You will have to go through these factors, because in exam they will be discussing a lot of things like what are the basis for this one. So factors influencing ionization energies, we can go through. First of all, atomic size. Atomic size is very important. Smaller atoms have higher ionization energies because they are very close to the nucleus. So atomic size matters. If it is atom is of bigger size, electrons will be away from the nucleus and under the lesser influence of the nucleus. So you need to check the atomic size. Then the second thing is nuclear charge. Inside the charge, if inside the nucleus, if charge is more, it means number of protons are more, then the nucleus attraction will increase, and this will lead to the higher ionization energy also. And third factor is electron shielding. Shielding is like hindrance from the electrons. So electrons, you know, are revolving around the nucleus, so electron repulsion will be playing its role. So electron shielding is also very important. More inner electrons can shield outer electrons from the nucleus, decreasing ionization energy. So electron shielding is resulting to decrease in ionization energy. And further is distance from the nucleus. Distance from the nucleus, if distance is more, then the further the electron is from the nucleus, the lower the ionization energy. So it's basically, these are four factors which are affecting the ionization energy. And the fifth one is electron repulsion also. So electron repulsion, increased repulsion among electrons can lead to higher ionization energy also. So these factors collectively influence how much energy is required to remove an electron from an atom. So collectively these five factors will be determining how much ionization energy will be required. Hopefully this is clear to you. You will have to go through the other 5 videos as well. This is the 6th video, so go to the playlist and go through all the videos. Don't forget to subscribe the channel and recommend this channel to your friends and class fellows, and introduce this channel to your respected teachers. Thank you very much for watching. Take care. Bye.